Hi everyone, welcome to this ECR webinar, which is focused on the role of building information modeling in accident-free construction. It is a great pleasure to have Professor Billy Hare and Professor Fred Sherratt today as our keynote speakers. Now, without further ado, I will ask them to first introduce themselves in a bit more detail, and then we will start the presentations. So please.
Thank you, Sina. I'll go first. I think my name's first on the list, if that's okay, Fred. I'll just share my screen and I'll have some PowerPoint slides, if you bear with me. Okay, and I'll just start the presentation. Okay, is that all good, Sina? Can you see my first slide? All good. Okay, so my name is Billy Hare. I'm Professor of Construction Management at Glasgow Caledonian University, and I'm also Deputy Director of the BIM Research Centre, which stands for the Built Environment and Asset Management Research Centre. I'm going to speak today on BIM and how it can be applied to occupational safety and health within a construction context, but also flag up some warnings that it's not a replacement for competence and it's not a replacement for good design. This slide might overlap with some that Fred has, who will be the second speaker this afternoon or this morning, depending where you are in the world. And just to cover what we do, we both are coordinators for Working Commission W99, Safety, Health and Wellbeing in Construction. And also, as well as the CIB aligning our work with the Sustainable Development Goals at Glasgow Caledonian University, we do that also with our research, which addresses sustainable cities, construction project risk and value management, where I reside in my research area, and building resilience and environmental impact. Some of the research that I've done recently, I just want to flag up that the ubiquitous advertisement that every presentation must have for your research to let people know what you do. I'm going to say a little bit about the top right-hand corner, which is a digital app, if I can be so bold to call it that, a digital tool to aid designers to prompt them identifying hazards in their work, which features in the presentation today and also has filtered in to some of the later developments, which I'm going to discuss as well. Another area that I like to undertake research on is worker engagement. And towards the end of this presentation, I'm going to revisit that because it's important as well. When I'm not doing safety, health and wellbeing research, I like to dabble in trying to reduce construction waste from an environmental and sustainability perspective. And I've done some work here in Scotland, funded by Zero Waste Scotland, which is a government body, looking at identifying the true cost of construction waste and indeed how to find the source of why the waste is arising so that we can reduce it. So you can find more detail on that within my research webpage, which will come later. So I want to look at, first of all, BIM for Health and Safety. BIM for Health and Safety is a UK group chaired by the HSE, the Health and Safety Executive. And for a number of years now, I've been a part of this group, which has been trying to promote all the good things that BIM can do for health and safety. And I just want to spend the first part of this presentation saying a little bit about that. The key areas that BIM for Health and Safety have been working in, it's basically an epicenter to bring together everything BIM related for health and safety in construction. The four main key areas that's on the screen: asset information and management, so the use of digital and BIM technology for when you're actually running facilities and providing information in real time. Pre-construction information, which is a specific legal requirement of the construction design and management regulations in the UK. And pre-construction information is essentially information needed at the early stage of construction, at pre-construction stage, that will allow contractors and those coming afterwards to manage information that will help them to manage risk. And the use of digital technology here is information provision has been useful as well. Design information modelling in terms of collaborating and its ability to bring in different disciplines and share information is another area that's allowed digital technology to produce something that HSE call a risk burden report, which I'll touch on in a moment in some of the later slides. And then the common data environment, which is a well-known term within BIM circles. And again, in CDM terminology, it allows for a contractor to develop a construction phase plan in a standardized way, which can allow health and safety information to be changed and transferred between different parties to the project. I'm going to focus on some specific projects that BIM for Health and Safety has been involved in and what's coming out of that. The first initiative here is known as the Construction Risk Library, and that's basically bringing together data that will allow designers and then those who come after to be prompted about different hazards if they're unaware themselves in terms of their own competence or knowledge and understanding of how hazards can affect construction risk on site and thereafter during use and maintenance. Now, the library is something that's born out of that research I spoke about earlier that I've done myself. And along the bottom of the slide here, you can see a narrative and there's words in bold. And the idea of the library is to give you a framework, a context in order to identify every facet of a hazard that you can try and basically eventually treat it with in a more targeted way. So in this example, falls from height is the risk category, whilst using a working platform is the risk factor. The MEP plant, the mechanical electrical plumbing plant, is the power plant is the element, and then it goes on further with another, in total 6 variables that can then be used to build up a digital library. The benefit of that, then, it gives far richer detail than what's been done before in terms of just putting hazard stickers onto BIM models in a kind of superficial way. And then that allows that to then the designer to, in a UK kind of context, to try and eliminate, reduce or control the risks through design. And the matrix you can see on the slide there is just one example of how the risk library can be linked to the matrix, which will prompt designers in order to identify and choose. So the designer, the human, has the final choice in which treatment from the matrix that they want to apply. But the idea being that you move towards the left-hand side there, the elimination, that's better all round for the overall project risk. So that has its benefits, but it also has some drawbacks if you have over-reliance on this to tell you, the digital technology to tell you the prompts, which I'll touch on and revisit later. The next initiative here is taking that information and then, as we've seen before in early versions of this technology, is tagging or pinning the data to BIM 3D or 4D models. 4D meaning including time and the sequencing of the works. Historically, the 4D modelling in health and safety has been rather rudimentary, and things just appear on the model on the screen with no thought given to how it's delivered, how it's transported, how it's installed on the site. But again, that's been addressed, and I'll revisit that as well in later slides. The next initiative that the BIM for Health and Safety is involved in is from a client's perspective in standardising data in a data schema, and then identifying what the client's needs are. How will this health and safety information actually help the client? And that's that particular project is the LTC project, which is the Lower Thames Crossing in London. Again, it's using digital technology, but this is an early stage. For example, the Construction Risk Library is about to publish the actual library as a free resource that any BIM model will be able to use. And in the future, they hope to make an app out of it as well. Whereas this is a bit more theoretical, but has the ability, again, to have more detail so that you can cover different aspects of the risk data. This last one, Initiative 3 here, is a bit suspect. It's the type that's a bit more Hollywood that I think could easily be misused. essentially using work schedules and typical Kobe type identifying of tasks and of elements of buildings and structures to identify and tag a risk rating to each of these work tasks in a program or a schedule or a bar chart, whichever terminology you prefer. And the idea is that by drawing the risk factors, which is a bit of a black box calculation, can then give you in the bottom of the slide, you can see a dashboard out reading that might give you an indication of how high and how low risks might be at different activities throughout the program. As I said, that potentially is useful and can use you to then, you can then shuffle things around and you can try different approaches, different construction methodologies, and how that might affect the risk rating. But you can see how if this becomes a bit of a black box technology, how it could be without adequate competence, could end up being misused or misinterpreted. I want to now move to how that could happen in a bit more detail in terms of misuse and misinterpretation of the technology. And I'm glad I've got Fred following me here, because I've used some of Fred's, with her permission, some of Fred's insights here as well. This particular one is of real interest. It involves the gentleman on the slide, Lieutenant Colonel Stanislav Petrov, who was a lieutenant colonel, as I said, in the Soviet Air Force in the early 80s, when by a freak of the technology at the time, which we would consider rudimentary now, picked up a signal that the USA had launched intercontinental ballistic missiles. And rather than be the typical soldier in following orders and reporting this to the Russian authorities, which would trigger World War III, he used his brain and he used his humanity and decided that it might be a glitch in the system, and waited rather than reported what would have been potentially a war-inducing launch of missiles from the USA. And as it turned out, it was a glitch in the system caused by sunlight bouncing off the clouds over North Dakota. That information I received from Fred and took it as good. I didn't do any research to check if that was true or not, but the principle is that it shows you how if you take the technology at its word and don't use your own experience and intelligence, then blindly following the technology could be catastrophic. And these two examples here follow on from that, but more mundane in terms of sat-nav. The number of times I've seen vehicles drive up the wrong way or park in pedestrian areas or end up in a lake because they've blindly followed the sat-nav. And a bit more close to home in the UK, the horrendous impact of the Horizon software on post office masters, which, if you've been following the news along the UK, was also catastrophic. And again, all because the authorities taken what the technology is saying as true, when in fact it had obvious problems. But could this happen in construction? Well, I've got an example here where this is exactly what's happened in construction in recent times. This is taken from a notification from an organisation based in the UK called CROSS standing for the, relates to the reporting of structural safety errors and near misses. In this particular one here, a chartered engineer was checking over a retaining wall, and the retaining wall was to be designed to a certain height, 1.2 meters, and the chartered engineer thought it seemed a little too small, and on further investigation found that the person, not necessarily an engineer themselves, had used basic technology which you could download off the internet to calculate the dimensions of the retaining wall, and it was deemed to be potentially too small and not able to withstand the dynamic loads of the wall. Fortunately, in this case, it was a near miss, if you use that terminology, and that it was not built that way and did not result in potential collapse of the wall and any catastrophe that could have went with it. But again, it demonstrates how just taking the technology and taking information that's churned out at its face value without your understanding knowledge can be fatal. Taking that idea of knowledge and experience, this is just, there's a paper listed in the bottom of this slide, which relates to early work I did. I must admit, this early work was when I was really skeptical about how BIM could improve health and safety. And in this work, we wanted to demonstrate how the designer's experience would affect their ability, regardless of how good the BIM technology is. And it was undertaken at a time when the BIM technology was still quite rudimentary in relation to OSH. What we did was we created a BIM model, and we created a number of fictitious hazards in the model that designers would have to identify. And we gave different categories of treatment of the risk. So in other words, we wanted to find out how many hazards the designer could identify, and also when they thought about the treatment, could they use their own knowledge and understanding to have a category 1 or category 2 elimination or substitution, which is better, considered higher up the hierarchy, than just offering to the contractor to provide a method statement or a PPE, personal protective equipment. Applying that as a numerical count, we found that the designers with site-based experience, designers that had spent time on site, were able to more readily and more frequently identify elimination and substitution treatments of hazards, as well as higher number of hazards. As it can be shown in the right-hand side here, the blue, meaning those designers with site experience, identified more hazards and were able to provide better, more effective control measures or treatments of the hazards through the design measures. From that, I did later research where we tried to replicate vicariously, I guess, the site experience by providing a digital tool that could provide that information where there was a gap for designers. We found that essentially that it was very useful for new graduates and students rather than for designers that have been maybe longer in the industry. We used a visual method here, and this is what's eventually, versions of this is eventually going to work into that construction risk library that I spoke about. But this slide here shows how the bottom row of columns are how many hazards identified by a control group, and on the top, the blue and the red. The blue is the before, and then the red is after. How many additional hazards were identified after the experimental group used the digital technology that we applied. If I move on to some quotes from Fred Sherratt, I've given your name here, Fred, just so that you can't accuse me of plagiarising. This all applies to what I've shown you just a moment ago. Consider whether and how the technology can see the people in the process, because if you don't, then you'll miss a lot. Consider how things can be fixed. Technology goes wrong, and that's obviously quite evident in the earlier examples I gave. And what fail-safes might they be, including the competence and the knowledge of the user. Consider the digital exhaust. That's a good term. I like that, Fred. Digital exhaust of any technology. What's the data being generated? So a little bit on data protection, that kind of thing. How could it be used or misused in using data to point the finger, for example, or if you have another agenda and you want to use it for productivity or other nefarious reasons. Don't ever forget the people in the process. And I just want to link on from that and show you some examples of that in terms of people in the process that with all this technology, we can't forget. This was taken a couple of years ago, and it was 2 news stories that were side by side a couple of days apart. And on the left hand, it was a story about workers worrying about hazards in a crowded tunnel project. And then a few days later, a construction crane topples over on the same project. In other words, the workers could tell when there was problems, but they've been ignored. And if you ignore workers in this construction industry, you do so at your peril. On the flip side of that, this is something that I picked up in Construction Digital Week a few months ago, where a company is now doing 4D simulations, but in a way that they should do in terms of utilising the workers, the site supervisors, to actually do a simulation of the build, but beforehand, before they get to doing anything on site, and then using the information and knowledge from the workers to identify where the simulation, the 4D simulation of how the sequencing of the works, including not just things appearing out of thin air, but actually, as you can see in the slide, the mobile elevated working platform, the delivery areas where people will actually be on the site. And then from that, identifying and reworking the work process so that it's safer. And I think this is the future direction, which is really going to work best. So just to finish up there, knowledge of new digital technology can improve OSH, as we can see, but over-reliance on this technology can be disastrous. Site experience for designers is, for me, the essential criteria here. And worker knowledge is even better if you can factor that into your planning. So thank you very much. And I'll now hand you over to Sina, who will link to our next presenter, who's Fred.
Thank you very much, dear Billy, for your great presentation. Your slides reminded me of my own viewpoint that whether we like it or not, whether we accept it or not, the people are the subject of activities in construction. And the more we invest on people, the more we will be able to take advantage of the technology and process as well. So thank you very much again for your presentation. And now let's continue with the next presentation by dear Fred.
Thanks, Sina. Right, let me just share. No, I want to. Oh, sorry, I managed to break that. Oh, hang on, bear with me. Sorry. There we go. Right. Oh, I love technology, me. Share. Present info. Is that working?
Yes.
Yes,
You
right.
just need to put it on the presentation mode.
I
Yes,
did.
now we can see.
Yes, right. Okay, perfect. Thank you, Sina. Okay, so interestingly, Billy and my talk, they will overlap and they will have little areas of middling interest. And Billy's raised some very good points that I'm going to add in on the hoof, as it were. So first of all, digital exhaust is, sadly, I did not coin that. That's Zuboff, a fantastic author. Do check out her book on the age of surveillance capitalism. It's fantastic. It has a lot of lessons for construction management researchers, and it's a great piece of work in and of itself. So with that acknowledgement made, so I was a bit naughty and tweaked my title, which I'll come on to later. But as you can see, I'm Dr. Fred Sherratt. I work in Colorado at the Construction Safety Research Alliance here, and I'm joint coordinator of CIB W99 with Billy. Here's some fun pictures that I like to show about me. So this is me proving you can run a job site with inch-long pink acrylic fingernails. That's me showing I can climb cranes. Some of my wonderful students over the years, some of the books I've written to try and help both students and researchers in construction safety. And you can see there the CSRA, that's where I currently work. And then obviously our W99 logo as well. Now, first of all, as I said, I've been a bit sneaky because the original title of this session was accident-free. And I come from a space where I'm actually more concerned with SIFs. So if you can see this graph, this is why. So this is the fatal and non-fatal injury rates for US construction. And you can see that the efforts are showing results. We are seeing a steady reduction in the number of non-fatal injuries. But if you look at the actual fatal injury rate, we have plateaued. We are not shifting the dial on how many people we kill throughout the year doing construction operations, and that plateau can be seen around the world. That's the same situation in most countries. So whilst we're improving workers having more minor injuries, and we're improving and reducing those numbers, what we've not done is be able to really focus on SIFs, and that seems to be where the next challenge will come. Now, there is a potential way of doing this. So I'm just going to introduce a particular theory before I get into the technology aspects, which actually might surprise some people because I'm not totally against it on this one, but let's see how we go. I'm sure Billy can come up with some good questions for me at the end if I've strayed too far from the right path. So the way I'm going to focus this is based on some work led by my boss, Professor Matt Hallowell, working with Professor John Gambattese up at Oregon State, and it's about energy-based safety. Now, energy-based safety is entirely focused on SIF prevention because research has proved that the things that hurt people are not the same as the things that kill people. This is partly why we've seen that plateau on the fatalities, yet we've been able to reduce other injuries, because we're two separate sorts of hazard. And the distinction is around the amount of energy involved. So accidents are fundamentally caused, if we want to go back to the very roots of physics, they're caused by the release or a lack of control of energy in a situation. Be that kinetic energy, be that movement, be that gravity, be that... I used to make a joke that nearly all construction accidents were caused by gravity. So what were we going to do about that? But this is very much tied into the theory of energy-based safety. And it's high energy that causes serious injuries and fatalities. And they're what's known on sites. And we're starting to see energy-based safety as an approach to prevention of SIFs spreading out across America and the rest of the world. And the way this has been translated into the vernacular for the site people is we're calling it sticky, shit that kills you. So this is the high energy stuff. This is the sticky stuff that we need to keep our eyes peeled for on sites. Now, when we're looking at high energy, and this is the piece of work that did the maths, we can see from the graph, which is taken from the 2017 paper there, that if you have a certain amount of energy, it's more often than not going to cause either a first aid, if that value is between 1 and just over 1,000 joules. And you can see on the graph as they go up, that the amount of energy, the larger the amount of energy, the more serious the consequence. And this makes logical sense, right? So if we have a threshold of around 1,500 joules, we start to get the most likely option, the most likely outcome being a serious injury or fatality. And that's where that threshold lies. So if we are looking at high energy hazards, those over that amount of energy, we're likely to be in a SIF situation. So those are the sticky energy releases or uncontrolled energy. And this is a great graphic that shows quite clearly what they all are. So you can see we have gravity, we have motion, heavy machinery and worker on foot, nearly always in the top 5 causes of fatal accidents in construction in any country across the world. And that's because it's a space where we have high energy and no really good controls for it. But you can see here there are others. Gravity, a fall of 4 foot. And again, that's including the maths in terms of how much energy that's going to release. Motion onto the vehicle occupant. We've got trench excavations, things like that. So these are all different sorts of energy, and they put to the value of the high energy that the most likely outcome is going to be a SIF. Now, the reason I thought I'd start with high energy is because this is maths. This is all done by calculations. And something that computers can do better than me, definitely, is maths. So never trust me to add 2 and 2. I am a social scientist. I do people. But when we're looking at high energy hazards and we're looking at energy-based safety, and if we are going to take that focus on SIFs, which is kind of where it needs to be at the minute, this might actually have a place for computers to help us. And I'll just leave that there for the minute. So how do we actually deal with these high energies? So the counterpoint to this, how we can manage this in practice, is using something called Hare. And Hare is a high energy control assessment. So at the moment, we do suffer in the construction industry because our main measure of safety is a lagging indicator. It's recordable injury rate, it's total recordable injury rate, it's accident frequency rate, it's whatever initials you want to put to it, but it's how many accidents you've had divided by number of worker hours normalized by 200,000. So we kind of calculate this pretty much the same everywhere. But of course, it's a lagging indicator. We have to wait till we finish the project to find out how safe we were. So what Hare does is it provides a mechanism through which we can kind of get an idea of how safe we are now. We can actually go out on sites and look for high energy hazards using the icons, using the understanding that we're looking for high energy here. We're not looking for kind of trailing leads, and we're not looking for other bits that would normally form an inspect. These are very much focused on high energy hazards. And for each high energy hazard, ideally, you need a direct control to control and contain that energy. And these have been developed through collaboration between my boss, Matt Hallowell, and his work with the Edison Electric Institute here in the US. And so these are the 3 defining characteristics that give you a direct control. It has to be targeted at the high energy, specifically. It needs to be installed, verified, and used properly. And it still needs to work if someone makes a mistake, because people are human, that we make mistakes. So we can't claim that we're improving safety by asking somebody to keep their head on a swivel. Have situational awareness, because people make mistakes. You will not be able to maintain situational awareness throughout the entirety of a day. And to ask that of workers is not actually very fair. So there are ideas around this very specific definition used to define the high energy controls that could be put in place. Now, interestingly, for construction work, we have a bit of a problem, because for about just around a third of the stuff we do, so the construction tasks we do, no such direct control even exists. There is no direct control for a worker and machine on foot. There is no direct control for work zone management when you're trying to work near vehicles for whatever reason, and the public highways. There aren't direct controls for a lot of things, and that's a problem. So work is ongoing to work out how we can develop better direct controls for construction work. Maybe we need to decide that we're going to do things differently to start with. We can unpeel the tasks and put them back together with built-in direct controls. That's research for the future. But at the minute, we're actually looking at how can we manage this on site. So interestingly, I'm going to start to get into the overlap, Billy, now between what we're both talking about. And given that this is maths based, given that this is kind of doing sums that I couldn't possibly hope to do, I think that we might have a space here, but we need to tread carefully. And I echo Billy's points to that end entirely. Now, BIM for safety, to go back to the first part of our title for this event, I actually realised I spoke first on this topic in 2013, which was over 10 years ago now, and look at the difference that we have in technologies. I did a CPD talk for the SIA, the Chartered Institute of Architectural Technologists in Bolton, back in 2013, when this was really first starting. And there were some teething problems. Billy's already alluded to them, and I think they probably still endure. So this was a graph at a conference, an image at a conference that I got quite excited about, because somebody did, Billy, what you said. They showed us the BIM model, they pressed a button, and a lot of edge protection appeared. And wasn't that great? Look how much safer that job is now with its edge protection. And I had to put my hand up and say, how did the edge protection get there? And then, of course, we have to admit that what you can do with a click of a button, you still need a worker either on full arrest or full restraint to actually put the stuff in place. So it isn't actually making things safer. You're just pretending that it can appear without creating a high energy risk. So there were definitely some teething problems then, exactly as Billy suggested. But I think it's interesting to think about the potential for kind of a mashup of high energy hazards and BIM and prevention through design effectively, which Billy also alluded to. So when we start looking at BIM models, whether it's through the process or design or the finished article as part of a design review, I think it should be relatively easy for something to be able to spot these high energy hazards. And as Billy says, training can help improve people with this. We can facilitate, and it has been proven, I believe, that we've done some research over here that shows that by using these icons, by using the sticky idea, we can get workers to spot hazards a lot more easily. Through what's also known as the energy wheel. You can get various stickers with them all on, and you can start to try and train yourself and people, including designers, of course, where these high energy hazards are likely to be. And it shouldn't be beyond the wit of man to be able to apply that to a BIM model using this particular focus in order to certainly enhance the ability to catch any high energy hazards, and put remedial work in, redesign, create a space where you could actually do that work much more safely using the high energy based safety approach, but also looking at how the design itself is produced ongoing. So there is scope to train designers on high energy hazards so that they are predominantly thinking, how can I stop somebody getting killed when they're building this? And that, I think, would be a step forward in and of itself. And of course, the technology has changed so much since that presentation I did back in the day when I looked a lot younger. But we've now got 4D BIM, of course, and Billy mentioned this as well. So 4D BIM is actually where we start getting the computer to virtually build the project. Now, interestingly, and I must confess, I have not researched this myself particularly, but I would very much hope, and Billy, this is where I'm going to pull on one of your comments right away, that the brains behind the scheduling in order to design it safely needs to be human. We need to have the algorithms and the tools that put a 3D model into a 4D model or concurrently develop the two. We need site experience in that space, because this is where we're going to start to see the realization of high energy hazards as the construction progresses. Because the high energy hazards on a finished building will be very different to when it's half built, quarter built, sixth built. I could obviously go on ad infinitum. So it is important that the 4D process that is embedded in the BIM model is crafted by people with the experience and understanding of how that goes together. But what we should be able to do is, again, draw on energy-based safety. We can start making the 4D model pay attention to high energy hazards specifically therein. And I think that will that is a potential area for future research that actually provides a good framework in order to start undertaking evaluative work of safety through the kind of design technologies that we're seeing now. And then, of course, to take this a step further, we put the magical wondrous AI thingy into place. Now, because energy-based safety is maths and computers can do maths, one would hope, she says optimistically, that the 4D model that is based on actual realized experiences and understandings of how things work, not just the AI pressing a button in its own brain and the edge protection appears. We need the appreciation of the nature of the actual tasks that are being asked to be done. But we could theoretically, and I can see no reason why not, train a machine learning model or an AI to actually be able to flag the potential high energy hazards where there is that threshold of 1500 joules is exceeded through the different types of high energy found on a job site, especially if we're doing the 4D BIM properly, which is rather than just using it as a tool for the quantity surveyors to make their valuations per month easier, we're actually using it to build in the digital space so we can see where the crane swings may have a problem, where we may have suspended loads in areas that we cannot maintain control. Remember, that's one of those high energy hazards that creates a vulnerability for a serious injury or fatality to occur if something goes wrong with it. So as long as we're actually embedding practical abilities within the 4D model, and therefore also within the what I'm going to call it AI, and I know that's not the right term for what I'm actually describing, but it'll do for now. But that needs to be trained by people with the experience. And we ought to, I mean, without wishing to sort of be a bit dramatic, I would hope we'd hurry up about this, because otherwise the AI is going to be doing the 4D BIM and we're going to lose the experience of the folks that have actually built things for 50 years, which we do not want to do. As long as that's trained together, there is perhaps potential here for BIM technologies to actually focus in on SIFs, not just accident-free, but SIF-free construction, which I think is where things ought to be aiming for now. And of course, this speaks to the prevention through design element that this could really, really enhance. But we do need to balance control. We shouldn't rely on AI to catch everything. All it can ever be, and to echo Billy's words, is a tool that helps us, but we should not lose the person in the process. I think that AI, it makes stuff up, it hallucinates, it has all sorts of issues within it. So it does need to be checked, but there is the ability for it to do the math, for it to do the sums that say, I think we've probably got a high energy hazard here. Does someone want to take a look? And I think that in and of itself will be a benefit for people as they go through the design and construction process in one, if they're doing the 3 and 4D BIM combined, which ideally we would hope they would be, so that the designers are fully embedded in that risk assessment process as dictated by CDM in the UK. So it can help and alert direct designers to things, can monitor the 3 and 4D BIM concurrently as it emerges to flag potential high energy hazards, and therefore creating a new way for PTD to kind of leverage both the technology and a focus on SIFs to really help us try and move that plateau that we're currently seeing. So, my key takeaways for y'all today. Energy-based safety is it's a good framework to target SIFs, and there it's evidence-based. It has the research, peer-reviewed research behind it. It's been empirically proven to help people spot high energy hazards in the field, so there's nothing to suggest that this is not the same case for designers. And we have a comprehensive, sort of a properly amalgamated 3 and 4D BIM model, AI could probably help spot the high energy hazards therein because it's very much a maths-based system. So we're not asking it to subjectively evaluate anything. It can simply do the sums. And that will hopefully enable it to flag to designers throughout the process, as the process is going, to actually point out where those high energy hazards may occur so the designers can revisit. We can redesign, we can think about how this building is actually going to be built in real life through the 4D approach, if we do it properly, to actually help us reduce those sticky hazards. I think this is a really potentially a fruitful area for prevention through design folks to get involved in. I am not one of them, but I think I kind of wanted to do something where I wasn't just being really horrible about technology all the time. But I think there is maybe potential here, but I would want to see the receipts. I would want to see the peer-reviewed empirical evidence that this could work. This, of course, just now is just an idea. So there is the potential, however, for BIM and AI to help us get to SIF-free construction. That's very specific. That's the thing we need to focus on as a community at the moment. And I think that's very important. But to echo Billy's points, we should not eliminate people from the process. And the idea of this is to help people do the process better. We need to help focus in now perhaps on PTD can pick this up and have a look at how that works with the models. And yes, I think there is always, Billy alluded to the Horizon scandal, various things like that. We do need to be very careful with technology. There is no way we could say, well, the AI's check the model, it's fine, because we can't have that guarantee within the tech. We still need people, experienced designers, to stay involved throughout the process, because there is the potential for it to go rogue on us, and we don't need false assurances, particularly when we're talking about worker safety. So if you're interested in my views on that, please do check out the comment. Yeah, I can do my shameless plug now, can't I? Do check out the commentary that was recently published in Buildings and Cities, the online journal. It's open access. It came out yesterday, I believe, which is my general warning about technology use in construction, and you can find that on my LinkedIn. I posted that reposted it a couple of days ago. But also, if you need to find out more about the resources around energy-based safety and things like Hare, all available on the CSRA website, and everything that we produce is always free of charge for folks to grab hold of. So I'm going to leave it there. I think people may be surprised at what I said there, but I think if we can leverage things to do the useful things, we should. But again, to echo Billy's caution, we really shouldn't let ourselves get overexcited and let it get ahead of us. That's when the risks could be realized. So thank you very much for your time, and I'm happy to take questions. So Sina, I'm going to stop sharing my screen now and hand back over to you. Thank you.
Thank you very much, dear Fred, for your wonderful presentation, which was also very thought-provoking. And now, as you said, so if there is any question, we would be happy to hear. If not, if our speakers have any questions from each other or comment on each other's presentation, that would be also great to hear.
Fred, one question and one comment, I suppose. The question relates to the HICA ability to manage multiple risks simultaneously. The criticism of most risk assessment is that it looks at individual risks individually and ignores the cumulative impact of multiple risks. I get the feeling, but I'm not sure, that the HICA high energy approach might be able to deal with that. So that's the question. And would you have a response to that? And before I sign off, the comment that I have is a bit more esoterical, in that there might come a point in time when all of this will be superseded by the combination of AI and robotics to completely remove the human from the construction process on site altogether. So I just wonder, there might be this convergence of the AI technology to aid our designers, and then all of a sudden a complete cliff edge where we drop off and it becomes academic, so to speak.
Excellent use of the term. Right, so to respond to your first comment, Billy, so Hare in and of itself isn't, it's not exclusively a risk assessment tool. You're actually going out on your site looking for capacity. You're looking for where you have high energy and you've got hold of it, which gives you an idea of how much you've not managed to control. And that might be none of your fault, because there is about a third of stuff that we do that there isn't a direct control. So it's kind of to give you an idea around safety capacity rather than anything else. However, I think in terms of a sort of the combination of risks within a space, I think because it goes for the SIF, it's really worried about, is someone going to die doing this? Is that the most likely outcome should something occur? So I think in those such situations, it's a kind of solo thing. However, it does have a calculator, because in some cases we do have more than one type of high energy, of course. So there is a calculator option. I mean, I'm being a bit naughty here because this isn't my work, because it's got maths in, obviously. But I thought the way that it did that enabled, it would be interesting to throw that out there, as these webinars are for, to see what ideas follow on from that, because it is a mathematical threshold principle of where people should look to try and maximize SIF prevention. I think your comment about the robotics thing is very depressing. I mean, it's going to be kind of the opposite of the Williamson tunnels, isn't it? Which is one of my favorite ever stories, which I'm going to tell you now, because I can, which was after the Crimean War in Liverpool. There were lots of men coming back from the Crimean War that had no work. And there was a philanthropist, Williams, up in Liverpool. And what he did was he employed these men to give them gainful employment, meaningful work, to build tunnels under the city of Liverpool for absolutely no reason at all. So actually, it's super interesting. And all he did this for was to contribute to the community by giving these guys some decent work to do. And if you go to Liverpool, you can go to there is a historic museum. You can walk in some of these tunnels. I know some of my students used to work in Liverpool, and one of the most common things was your piling rig went through a tunnel, or you found it, and it's literally, the area under Edge Hill is riddled with the things. But to me, that's kind of the absolute opposite, right? You've got someone putting people to construction work just to give them a sense of, well, the meaning of life is to give life meaning, of course. So it starts tying with that. The thing that makes my heart think is, because if we take construction workers off the site, what are they going to do? And I love construction work. It's good work. It's fun. You do something collectively. You're physically creating something. It's all the good stuff about being a human, really. I know when I stopped on site, I had to suddenly start doing an awful lot more craft, because I wasn't making anything anymore. And it's a fundamental human essence to want to make, to create, to contribute. So I think, yeah, I fear, because the rise of technology is exponential. It's not, it's going absolutely through the roof. So Billy, you might have a very good point that by the time we get anywhere with AI helping us through the design, that the build has already been taken over by robots in factories who are just throwing panel systems together, throwing big, the big riser combinations, all the M&E chunks, and then they go to a site and another robot just lifts it up and pops it in. And God, that's a bleak old day, isn't it? Luckily, I'm quite old. So anyway, thanks.
Sorry, I was just going to say, the theory goes, though, that should then allow the population to follow your vocation in life and do what you want.
We've had that before. The Leisure Society in the 50s, right? It's like no, why do we live in such ahistoric times? So in the 50s, when everyone had, you know, like the robot maids and all that sort of thing, that was the plan then. Robots were going to do all the boring work so we could live in leisure. That's why it's called the Leisure Society. Check it out. This is a proper thing. And now we're hearing the same thing again, but people have like 4 jobs and absolutely no time to do anything. So I'm not quite sure how this is working out or who it was working out for. But I think there's that very famous quote, isn't there? I don't want AI to do, I want AI to do the dishes and clean the house so I can do the art and the music. I don't want AI doing the art and the music so I can do the dishes and clean the house. And that seems to be kind of where it's going at the minute as well. So that's quite interesting.
That's where we've ended up. Yeah. Okay.
Thank you very much. So as time is almost up and there seems to be no question from our participants, I would like to really express my gratitude to our keynote speakers for their wonderful presentations and to conclude this webinar. Thank you very much again.
Thank you so much, Sina. Thanks for having us. Take care, everyone. Bye now. Stay safe.
Bye.
Bye.